For those online that with us, appreciate your time today. I won't cover the, the basic intros that we've already done. What I am going to cover over the next hour is two sections, actually. We've done kind of individual sections on envelope, on ventilation, lighting, and then lighting controls. And then this is going to be about the final two sections of the efficiency code. Kind of the energy efficiency requirements and then performance modeling, because they kind of go hand in hand. They interact a little bit. These are kind of the learning objectives, what tools you can use, and how to kind of calculate some of the savings and things like that. And then at the end, there was a really big change in 2024 with the efficiency option. It goes to a completely new method. And trying to talk about it is a bit overwhelming because there's so many potential options. The idea is to provide increased design flexibility, but I think the best way to actually learn it is to go through an example. So we'll wrap up today by kind of picking a hypothetical building, and we'll just kind of work through how does this look in practice, because working through it in practice is a lot less intimidating and makes a lot more sense than just looking at big tables with a lot of numbers. But we'll start with 2018, the commercial efficiency options. There's a list of 8 different options available to you, and you have to pick one. The other option is to do total building performance. I mentioned that in the envelope as well as the ventilation, that you get to bypass a whole bunch of the text of the code by using energy modeling. There's some things that are still required, and we'll go through that. But let's start by looking at the additional efficiency options. So this is what is on the books in Idaho right now. You've got to do at least one of these things. You don't have to do all of them, but just one. You can have more efficient HVAC, just the lighting power, do better lighting controls, like Dylan's just talking about. You can have on-site renewables. You can use dedicated outdoor air systems, better water heating, more insulated envelope, or a tighter envelope. So for more efficient HVAC, say we wanted to do that. All we have to do to meet our additional efficiency requirement is to do just 10% better than baseline. Okay, so I believe the intention of this last section of code, the additional efficiency option, is that some options make more sense for some projects compared to others. And this is giving you as designers a little bit more flexibility, so that not every building has to comply with all of these. You get to just choose from this menu. So if you want to do more efficiency through HVAC, you have to make sure that this applies for all the equipment. And then if you're using a VRF system, it has to exceed the requirements which are set forth in ASHRAE 90.1, also by 10%. So an example of this, we've got a gas boiler. The minimum efficiency by code, if we just look up our HVAC efficiencies in the mechanical section, C403, it varies by the size. So if it's 300,000 BTU per hour and it's a gas boiler, by just the basic code, we have to have an 80% efficient furnace. If we want to achieve this additional efficiency requirement, we have to bump that up by 10%. So we have an 88% efficient furnace. Pretty easy to do with a condensing boiler. Some of the condensing boilers now are like 95% efficient. We'd also have to do the same for our air conditioner, right? If we were originally looking at an 11 EER, we have to bump that up by 10% to a 12.1 EER. There's 13 or 14 EERs, so it should be pretty easy to find one of these. We just have to kind of go a little bit above, 10% better. It's the same for lighting power, right? We can choose better HVAC, we can choose better lighting. Dylan just walked us through kind of the lighting power of allowances. So once you know what those are, just go 10% below that. This is very easy to do with LED now, particularly on the 2018 code. We can get a ton of lumens out of our lights now without using as many watts. There's also, great incentives available from Idaho Power. And if you haven't used their lighting checklist, I know Dylan likes to use his own spreadsheet, but there's also a lighting tool available from idahopower.com, savings for your business. There's the lighting tool, and it's an Excel spreadsheet. You can also watch a YouTube video on how to use it or reach out to our lab. But the idea is here in code, all we need is just 10% fewer watts. So if we've got a warehouse and we have an allowance of 25 kilowatts, instead we install 10% less, or a capacity of 22.5 kilowatts. We still provide the same amount of brightness lumens. We're just doing so through either fewer fixtures that are more efficient, or just generally just more efficient fixtures. So this is a very easy one to choose. So if you have a client and they're like, I need to meet this section, what is the easiest way to do it? Lighting is probably the cheapest, quickest go-to for this, for meeting minimum code compliance. The other option is to do better lighting controls. Somewhat similar to the 2024 controls Dylan was talking about, making sure that there's continuous dimming, individual addressing of fixtures, luminaire level lighting controls are a great way to do this. So specify LLLCs and you automatically meet your section 406 for 2018. Adding digital controls, sequence of operation is included in construction documents and do some efficient. Again, you could do this just by specifying in LLLCs. The other option that is available in 2018 is to have 3% of the building energy met through on-site renewables, or 0.5 watts per square foot of the conditioned building area coming from renewables. In Boise, that could be geothermal, where we look at that go. Sorry, one of my slides is lost in the midst of that. So here at the water center, instead of using just boilers, we're connected to the city's geothermal district. That would count as certainly more than 3% of our building energy. Now, with the 2024 code, if you're doing it in a state other than Idaho, there are specific renewable requirements for on-site generation that has been redlined out in the proposal going before the Idaho legislature. So even if Idaho does move to the 2024 code, 2027, the renewables would not be, well, one, we wouldn't be looking at the same checklist, moving to a different checklist, but renewables would not be required on 2024. One of my favorites of the 2018 efficiency options is just use a dedicated outdoor air system. It's not brand specific. It's just a matter of separating your ventilation from your heating and cooling. And a lot of incredible resources available for this from betterbricks.com and the Northwest Energy Efficiency Alliance, which again is sponsoring these talks. So thank them for your end of year CEUs. and our time to kind of help you with any of these issues. There's some really good case studies on dedicated outdoor air systems, and even locally, one of the contractors they've used is Jordan Pratt from Energy 350. He's given presentations at ASHRAE and for our VSUG lecture series. So if you go onto our website and our YouTube channel, you can hear him speak about dedicated outdoor air systems, particularly in cold climates in Idaho, and their cost effectiveness. So you can use VRFs, you can use mini split heat pumps, you can use radiant systems. All of these count as a dedicated outdoor air system. And once picking this one would get you your additional efficiency credit. For high efficiency water heating, this only applies to certain building types. Residential, healthcare, restaurants, or where the hot water load is 10% or more of the building energy. I would note, anytime you are doing any efficiency option, say it's dedicated outdoor air system, check with Idaho Power for their incentive programs, because they might offset some of the costs there. With high efficiency water heating, Intermountain Gas also has an incentive program for high efficiency gas equipment. So reach out to Kathy Wold and their efficiency team as a way of achieving this credit and also saving on some capital costs. The other option, instead of high efficiency water heating, is doing some waste heat recovery, using the chillers as preheat for your boilers, or on-site renewable energy. That could be solar hot water. The book that I've been using by Allison Bales, "The House Needs to Breathe," one of the final chapters in there is on water heating, so my class had to go through that Friday. And he argues that solar water heating is dead. At least it was in 2014, and now running the numbers again is really, really dead. Because the cost of plumbing solar hot water, and you still have a backup system that's required for cloudy days and things like that, it adds up so much that the infrastructure tends not to pay itself back. If you do want to do some solar water heating, what you can do is just add a solar photovoltaic panel, your PV panel, and then plug that into an electric boiler. At that point, it's just cheaper infrastructure, simpler, and you still get the same benefits. So, I still love the idea of solar water heating and some of those kind of DIY things that you can do with soda cans and things like that. But economically, solar panel photovoltaics have just come down in cost so much that from a cost perspective, that tends to be the cheaper way to go rather than using solar thermal. But if you really wanted to do it, your client really wants to do it, it's super popular amongst the architecture students upstairs in their thesis projects. You can get a credit for it and meet the 406 checklist. That'd be one way to do it. The other option is to use a better thermal envelope. So what we started with today, talking about how do you put in these layers to make sure that there's no thermal breaches? You look at the total U factor times the area for each of your different components. This would be your walls, your roof, your foundation, and make sure that the one that you are designing ends up being 50%, 15% more effective. It transfers 15% less heat out total. That doesn't mean your new wall has to be 15% better than your old wall, and your new roof has to be 15% better than your old roof. What it could be is your roof is now 25% better, and your wall is 5% better, as long as it adds up to a total improved performance. making sure that you are summing kind of all of those factors for those. So it gives you a lot of flexibility. Maybe your client really wants a green room or something like that. This would be a great way to enhance your thermal envelope and give the client what they want, right? So you can, or maybe noise is a really big concern. So you're using triple pane windows or some continuous insulation on the exterior, right? Any of those things could potentially improve your overall thermal performance and meet kind of design criteria with kind of non-energy benefits, if you will. An option in 2018 that's no longer going to be an option in 2024 is to do testing to verify the air leakage rate of less than 0.4 CFM per square foot. Right? This morning, I mentioned in 2024, now this is a requirement. Pretty much all new commercial buildings in Idaho, if 2024 is adopted, have to do testing. Back in 2018, and what's on the books right now, we didn't have to do testing, but it was encouraged, and you can get this additional point by doing so. So maybe if you have a building that is going to be meeting the 2018 code and you want to get ready for the 2024 code, this would be a really good thing to do. Figure out who the commercial envelope testers are in the valley that could do a lower door test on a portion of the building. Figure out how it works, what the timeline is, all of that, to get ready for potentially having to do that for every building in any jurisdiction that is adopting IECC 2024, which could be Montana, major cities in Wyoming, and other jurisdictions as they continue to adopt it. So in 2018, if you just do what will be required as a minimum, then you get this additional efficiency credit, and that could be your pathway through 406. Okay, so those are the options, your list of 8 different options that you could choose from, right? In order to achieve this extra efficiency credit in 2018. As I mentioned, 2024 is the whole other system, and so I'm going to end with that. In the meantime, I'm gonna jump ahead a section to section 407, which is about the total building performance, essentially using energy models for code compliance rather than going piece by piece. For our total building performance, this is based on costs, not use. So if you're looking at your energy use intensity and your kBTU per square foot over the year, that's a really important metric, and it's what we use at the lab to see how efficient buildings are. But the energy code is less concerned with that, and it is more concerned with the actual costs. That really depends on your fuel sources and where it's located. So if you have a building that is going to be using natural gas, you can't show in the model that you're using electric resistance heating. Right? The fuel sources between the baseline and the future model have to match, and so you can't kind of game the system that way. And you also have to make sure that you're not doing kind of a Mickey Mouse model that doesn't actually make sense. There's a whole list of criteria of what the model needs to look like, what software needs to be used. It's based on ASHRAE 90.1 Appendix G compliance. So it's actually, it launches you from IECC code over to the ASHRAE code. It says, look here for how to do a proper energy bubble. There's a couple pages in IECC that kind of walks you through the basics. Essentially, you are running an hour-by-hour simulation over a typical year in your climate and using local rates. And you have to make sure that the geometry of both the baseline and your proposed building are the same. What you're adjusting is anything that you might have chosen different. Maybe it's a different HVAC system, maybe it's better insulation, but you can't say, oh, well, my baseline building has, twice the square footage of my actual building. You can't do that. The square footage and everything have to match. And it will also guide you, ASHRAE 90.1 will guide you in terms of what your baseline HVAC is going to be. Depending on the software that you choose, whether it's Open Studio or Code or even Revit, I'm pretty sure, a lot of them already have baseline generators in them. So you can just click a button and it will follow the template and the requirements from ASHRAE 90.1 because it's a fairly common process. And it will generate that baseline building for you that you can then adapt. Now you have to double check, can't just completely shut your brain off because sometimes there can be errors in that. But it is, it's not as difficult as it used to be. A lot of people have kind of come along and built some of those tools into these programs, which is very, very helpful. You still have to meet certain code requirements, though. Those requirements include making sure that your air leakage is still the same. You still have to have the minimum equipment efficiencies, economizers, which I mentioned earlier this morning, a total lighting power density. So you have different controls between the two, but you have to make sure that you're not exceeding your basic lighting power density allowance. You're matching that service water heating, and you still have to have commissioning. You can't just have your model saying this is how my building should perform. You actually have to have commissioning at the end to make sure that it at least should be performing as the model. For future codes, so I want to talk about what is in 2024. It switches from this choose one of 8 options over to a points-based system that is based on the building type and its climate zone. The performance section remains pretty much unchanged. The table gets a little bit clearer. And if you haven't used performance modeling yet, I highly encourage it. Not just because I think energy models are cool, or that's what I spent like too many of my years doing in my dissertation, but it allows a lot of increased flexibility, right? You get any window to wall ratio that you want. It's focused on costs, so it makes sense from a bottom line perspective for the building owner and the occupant. You can also use energy models to help with the commissioning, and you can use the energy models for more accurately sizing your HVAC equipment. And that might end up reducing the capital costs a bit as well. So a lot of reasons to use performance modeling, but if you don't, that's okay. It won't hurt my feelings that much. We still need to use section 406, which is some sort of efficiency option. Let's go ahead and look at exactly what that is. Rather than looking at these tables, I'm going to switch over to the online version. You have to meet a certain number of credits. There's no Chrome on here. Okay.
Oh, there is. It's just not. It's you gotta hit that start. Okay. Yeah, it's not on the default.
And is the screen sharing clock?
I believe it's set to the PowerPoint, so you'll have to.
Okay, so let me stop share.
Yeah, and then just do the actual.
And I want to share my entire screen. Okay, and I want to IECC 2024. Doesn't like that. Well,
Let me see if I can get it over here.
could be a problem. It was working this morning.
Oh,
The website down.
I think it might be down.
Something happened between 8 a.m. and now.
Right? Yeah, it didn't happen this past weekend.
I mean, I'm on the Wi-Fi and it's working great. Just so you know, I'm on it right now.
Huh.
I think it's guest Wi-Fi, or I guess get on the guest Wi-Fi. And you're streaming right now, right?
I am streaming. Yeah.
So
Well, I'm trying to do it and
It's not letting you.
anywhere.
Is U of I's firewall blocking?
I think it might be that.
Why is it blocking it now? But it was
It blocked me from Don and Charlie's for like an entire month.
military blocks everything.
Okay. Well, that is a bummer. Okay. This is what the table looks like. So the number of credits that you need to achieve in 2024 is should have got the correct slide number here. There we go. It's a bit thrown off now that I can't access. Okay, so we've got the different building occupancy groups. Here we go. So R2 and R4 would be apartments or residential care. I is institutional care. R1 would be hotels. B is businesses, restaurants, retail, education, and then storage, and then everything else. So Lee, you've been with us all day. Hats off to you. What sort of building would you like to kind of choose to kind of go through this checklist? You had an example project.
Can we do mixture? Are there building mixtures? What happens if it's a building mixture? Like right now, I'm doing an energy audit on a. It's got bays.
Yeah.
Like for tanks and stuff to
Yeah.
work on them, and it's got office spaces, and it's got a lab.
Okay. We'll put that under other. So it'll be under all other, and it's climate zone 5B. So that means we need to achieve 36 credits, depending on from our tables. Okay. And then depending on the occupancy group, right now we're looking at R2 and R4. Online, I would go to the table that applies to all other, but for now we're going to say, okay, this is residential. Depending on what we select.
Yeah, let's do residential. Let's do residential for all of it.
Okay, let's do residential. Okay. And then we get to choose, right? We've got, okay, just keep in mind, okay, we're going to do residential. We've got to achieve a lot of credits for residential. We've got to achieve 90 credits. And we're in climate zone 5B. So then we have to go through and say, okay, how are we going to get to 90 different credits? It's not a matter of just picking one of these anymore. We might have to do some combination that is going to add up to all of that, right? So we could add a better envelope, right? We've got 15% better envelope. So that gives us 10 credits. Okay, so we've got 10 of 90 right there. We're doing reduced air leakage. So we still have to do testing, but if we come in lower than that testing requirement, then we could get up to 16 credits, right? If this was in a colder area, if this was further east, like towards Idaho Falls or something like that, and we were in climate zone 6B, we'd get far more credits than that. So the idea behind these tables is actually to push you towards what's most cost effective and what's most effective for that particular building type and in terms of efficiency. So, but if we're in 5B and we just start adding these up, at this point we've got 10 plus 16 by doing a better, tighter envelope, 26. Still have a long ways to go to get to 90. We've got down here, boy, it's cut off, so I'm trying to figure out what that might be. I believe this is hot water recovery. We could get 27 points for that, so that would get us to around 60. So we'd still need more. This table continues to go further down, and we'd have to kind of just figure out piece by piece how we want to put this together to reach those 90 points. Again, if we chose something else that was a institutional or mixed or office or something like that, we don't have to do quite as much to our building, still need it. I'm going to try one more time to get online to the IECC digital codes, and no, the device is going to block me. I'm sorry about that. That's frustrating because I was walking through this morning. So just know that it is an expansion, that this table continues to go further down, and it covers all the 8 topics that we were talking about earlier that were in 2018 406. So using a dedicated outdoor air system, that's going to get you a ton of points. Things like commissioning is going to improve. Lighting and lighting controls, those are still options. And so we just start kind of pulling our points together. We don't have to do just one and leave everything else, and we don't have to do everything. We just have to do enough to meet those particular things. So in terms of like takeaways from these final 2 sections, it's essentially just 2 things, and possibly third. One is just consider performance modeling. Dylan occasionally gives a presentation on the architect's business case for energy modeling. The energy code really pushes, it doesn't explicitly push you towards performance modeling, but there are subtle indications that maybe you should do performance modeling because it makes the rest of the code a lot easier. You get to bypass really big sections. You don't have to do as much, prescriptive documentation like with your ComCheck. It's more a check at the very end of our design goal is to make sure that this building costs less to operate than a conventional one. And if you can show that realistically in your energy model, then you get a lot more flexibility and hopefully fewer headaches of code compliance. The idea is to make it simpler and more effective. Okay? So energy modeling can help with that. It can also help with just dialogue between the architecture team, the engineering teams, the construction teams, as well as the owner, to say, okay, we're not just looking at the first cost for this building, but we're going to look at the cost of operating for year 1, for year up through the next 10 years, up to the next 20 years. And this is especially valuable for, institutional owners, right? Whoever's going to be paying the bills for the next 20 years. Look at that kind of longer term horizon for the return on investments and do these what if scenarios. What if we put in a dedicated outdoor air system? Maybe it does cost an extra, $5,000 or $50,000 right now, but we end up saving $20,000 a year, and so within a few years that actually makes sense. So consider performance modeling, consider kind of long-term costs, and then especially in 2024, and even before 2024, like right now, we're still in the 2018 system, but if you want to look at what are the most kind of cost-effective efficiency options, this table is a really good guide. It will guide you towards research that has been done by Pacific Northwest National Lab and the National Renewable Energy Lab on, okay, given this climate type and this building type, where do you get the most points? That tends to indicate what has been most cost effective for that building type in that environment. And that's kind of a good way to start working with the engineers, with the owners of saying, here's why we want to do a better envelope or wastewater heat recovery or a dedicated outdoor air system. Not just take our word for it because it's cool or because I'm going to get a kickback from some manufacturer or something like that. It's actually showing, okay, what's most cost effective. So even before it's required, before you have a 2024 project, get to know the table a little bit. Make sure that your firewall allows you to access IECC codes. Normally you can, and it's you can't do like screenshots or downloads from it unless you pay, but you can read it for free and navigate the system for free. So just kind of do a hypothetical project and walk through and figure out what would I need to do in order to meet those. Is there a question from online?
It's background, Mike.
Background. Well, if you do have questions, feel free to reach out to me by email. Reach out to you can just Google Idaho Energy Code Collaborative. And you're welcome to join those meetings whenever. They're posted on there. We would love to hear from architects and engineers that are dealing with the energy code. What works well for you? What headaches do you have? What amendments should be made specifically for Idaho? Please let us know so that we can kind of take that into account for the next cycle. We'll see what the legislature does in February or March. I don't know, they're organizing this May or June. There might be a panel discussion for the ASHRAE meeting.
Yeah, so the June chapter meeting, we're going to have an energy panel discussion, and that will, I chose June because hoping the legislature will have decided things by then, so we can talk about the incoming changes, what they are, what they mean. Everyone online, please keep in mind that if the legislature passes the new codes for 2024, it's not immediate. Okay, there will be a grace period. And during that grace period, the lab and other organizations, we plan on doing as much training and informing of you of those changes and what you need to be made aware of. Okay, so don't freak out.
If it gets all approved, everything's done, how long before you think it's produced?
It would probably be January of 2027 before it would be implemented.
So we would
about
have
a year and change from now.
Yeah. We just wanted to make everyone aware this is what's coming next year. Please, consider it and start, downloading and analyzing it.
Yeah, and the hope this last year was to get a lot of feedback while they were just still considering should we move from 2018 to 2024. And so that's where a lot of these red lines came from. It was pushback from builders, from different engineers saying, hey, this is maybe a good idea for another climate, but not necessarily for Idaho. How can we simplify it and make sure that it's cost effective for Idaho? And so those are the kind of the red lines and the discussions that happened over this last year. That's the result of that. Sometimes those can be really contentious because you've got people with very different philosophies in the same room and different business interests. I would say this year was remarkably non-combative. It was I don't think there were any raised voices. I think the biggest concern actually came out of snow load calculations, because that was changing a little bit, and the code family, not necessarily dealing with the energy code. I was encouraged because I felt like there was good compromise reached between different groups. And an indication of that was that it was a unanimous vote from the Division of Building Safety, which included a representative from the architects, commercial developers, consumer safety advocates, fire, and others on there as well. So I felt like that was a good indication that we work together to figure out something that should hopefully appeal to Idaho. That would be, too far out there, demanding too much upfront, and also not sacrificing ending up with very high operational costs on your programs.
There's one last thing for me I'll say is just give section C406 a chance. I know at first glance it's going to seem really, really overwhelming, but I promise you it gives you the flexibility that I have been hearing people request and demand. So
yeah, we did look specifically and the code collaborative at is this too much? Is this going to take up too much design time on the front end to implement? And should we just remove section 406? One thing that I didn't mention because I was going to show it online is that there are additional equations for 406 in 2024 that factor in additional renewable energy credits. Those are redlined out in the Idaho proposal. In the IDAPA rules going before the legislature, there's no energy monitoring required, and there's no renewable energy or renewable energy credits that are permitted. I'm not going to push you to add any renewables. It's not saying you can't. It's just saying you're not going to get credits for those in this table. So you have to. So in a sense, it simplifies this process quite a bit, because there is this weird balancing act of like, well, the code is kind of pushing for renewables for increased resiliency. But how much those renewables offset like your efficiency, that gets kind of wonky in terms of costs and things like that. So by just kind of striking those out in the Idaho proposal, you end up with a simpler equation that's much closer to that. Like you're just kind of following getting a total number of these credits without having to worry about adding renewables in there. Again, you can see the IDAPA red lines. They have yet to post, I think, the final version online, but we also have a copy that we're happy to send out. So that's one simplification that happens. And when you actually do walk through and use it, we heard positive feedback from several architects, even those that are dealing with 2024. And this is actually came out in 2021. So any architecture firms that are using the 2021 code are already kind of using this table. And they really appreciated the increased flexibility of this, that you get to kind of choose points from a few different categories, and it helps kind of guide what's worth our time to look into. Like, is it worth our time to put in all these extra lighting controls now that LEDs are so efficient? Maybe not, but we probably get a lot of gains from having tighter envelopes or using dedicated outdoor air systems. And this table kind of helps you along that way to at least emphasize what should some of those designs consider. Right. Well, I appreciate everybody's time today. Especially you've been with us all day, as well as I think a few folks online. So this is again not the end of the story. This is kind of where things stand at the end of this year. Things can always change, but we hope this provided an overview of where we are right now with 2018 and what might come down the line with 2024. And highly encourage you to, engage with the Code Collaborative if you want, and reach out to us if you have questions.
Thanks.
Thank you, everyone.